Hello everyone, welcome to the new video. So in this video we are going to discuss about non-deterministic finite automata, that is NFA. So let's see the formal definition first. So any finite automata will have 5 tuples and those are m is equals to q comma sigma comma delta comma q naught comma f, and we'll understand these things with an example first. So let us take a simple example. Let q naught be our initial state, and there's a state called q1 and another state with q2, and let q2 be our final state. And q naught on 1 goes to q1, and q1 on 1 goes to q2, and q1 on 1 also stays on q1, and q naught on 0 loops on to q naught. So let us understand these things now. First one is q. Q is the set of all states. So in this example we have 3 states. Those are q0, q1 and q2. So in this example q is set of states, that is q0 comma q1 comma q2. And the next one is sigma. Sigma is a set of all input alphabets. So here what would the sigma be? We got 2 alphabets, that is 0 and another one is 1. So we have 2 in our set, that is 0 and 1. The third one is delta. It is a transition function. So we'll talk about this in a minute. Next one is q0. Q0 is our initial state. So in this example q0 is the initial state and also q0 is the initial state here. So q0 is equals to q0. And the last one f, which stands for set of all final states. So what all final states do we got here? We got only q2. So it is q2. So let's talk about the transition function now. So the transition function in NFA goes like this. Q cross sigma maps to 2 to the power of q. Here q can be any of these things, that is q0, q1 and q2, and sigma is one of the input alphabets, that is 0 or 1. So what does this thing means is, so any state when applied on an alphabet will maximally have 2 to the power of q states. That is the difference between NFA and DFA. While DFA has one state for one thing, that is if Q0 should have both zeros and 1, and Q1 also should have 0 and 1, but here we don't find 0 for Q1. So this is the difference between NFA and DFA here. So let's try the transition functions here. The first one is delta of Q0 when applied with 0 stays on Q0, and delta of Q0 when applied on 1 goes to q1, and delta of q1 when applied with 1 either goes to q2 or stays on q1 itself. These are the transition functions for this NFA example. I hope you understand the formal definition and also the example. Thank you.